Hello, discrete math fans. Let's take these statements and write down their negations. For all x and y in the rationals, x plus y is an integer. All dogs bark. For all n in the integers, if n is odd, then n squared is odd. Alright, so parts A and B are pretty straightforward. Part A turns into there exists x and y in the rationals such that x plus y is not an integer. So remember, you change a universal quantifier into an existential quantifier and then negate the inside. And then for B, all dogs bark, we could say there exists a dog D such that D does not bark. If you want to avoid using the formal language, then you might say there is a dog that doesn't bark. And then for part C, we're going to need two stages here. So first of all, in order to negate a for all, remember, the for all turns into a there exists. And then we have to put the negation on the inside. So the statement, if n is odd, then n squared is odd, gets negated. And then in the second stage, we're going to work out how to do this negation down here. So that's what we're going to do next. We're going to negate that if-then statement on the inside. So remember that an if-then statement can be rewritten as an or. In particular, we have this logical equivalence that P implies Q is logically equivalent to not P or Q. And then remember that the way we can negate that is by using De Morgan's law. So the negation of P implies Q is P and not Q. That means our final answer is going to be there exists n in the integers such that n is odd and n squared is even. You should notice that this part here, that's the negation of the end of the original statement. The original part had n squared is odd. Now this gets negated into n squared is even. Okay, that's all for now.